Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: the EU is reversing course and quietly easing its planned ban on Chinese-made chips. The original ban was driven by security concerns, but the auto industry pushed back hard, and Brussels has now had to carve out exceptions. Today, we'll dig into why this U-turn happened. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Think of today's story as a regional union trying to ban a very specialized bolt made in a neighboring country, a bolt used in the critical joints of large construction cranes, and then having to walk that ban back the moment the crane maker screamed. So sit back and enjoy. Here's today's news in one picture. We'll lean on this crane bolt analogy all the way through the opening section. A regional union announced it would ban the use of a specialized bolt made in a neighboring country. This bolt sits at the joint connecting the arm and the base of a large construction crane, the kind used to build skyscrapers and bridges. Because it's load-bearing and directly tied to human safety, the quality standards for this bolt are extremely tight. The moment the announcement came out, crane manufacturers raised a massive complaint. If you ban this bolt, we can't build cranes. All the construction sites stop. And the union hurriedly said, okay, we'll allow exceptions. That's the essence of today's news. Why did the union try to ban the bolt in the first place? The reason was a security concern. Relations with the neighboring country had deteriorated, and the union decided relying on bolts from that country is dangerous. If they cut off supply when it matters most, we're in trouble. Wanting to reduce dependence on a specific country for critical infrastructure parts is, on its own, a perfectly understandable line of thinking. The direction of reducing dependence is by no means wrong. So the next question is, just switch to a different bolt, right? But on safety-critical machines like construction cranes, the bolts you're allowed to use are strictly defined. To use a new bolt, you first have to put it through testing. Is this bolt safe to use in a crane joint? And obtain certification. It's not enough that the shape just happens to match. If the bolt doesn't meet the spec, you legally can't use it in the first place. So the line, just ban the neighboring country's bolts and switch to something else, simply doesn't work in the real world. So what does getting certified actually involve? First, you apply to a testing institution. Then you go through multiple inspections. Strength testing, durability testing, corrosion testing. That alone takes several months. And even after you pass, you still have to find a manufacturer who can produce the new bolt, place an order for the volume you need, and wait again for delivery. At a construction site, that creates a chain reaction. No bolts in hand, no crane assembled. No crane assembled, no construction. No construction, no building. The political decision was completely disconnected from the reality on the ground. The point of this analogy is simple. Banning something is easy, but having a replacement ready to drop in the next day is a completely separate problem. Swap the crane bolts for semiconductors. Swap the crane makers for automakers. And the EU-China story we're talking about today maps onto this analogy almost one-to-one. From here, let me walk you through what this actually looks like in the real semiconductor industry. Today's news is that the EU is adjusting its planned sanctions on Chinese-made power semiconductors and is moving to allow certain exceptions. The European Commission had originally been pushing forward with the restrictions, but pulled back in response to strong opposition from the auto industry. That's the U-turn. First, let me explain what power semiconductors are. These are chips that control electrical power, and they're essential components in electric vehicles and hybrids. They drive motors, they control battery charging and discharging. A modern EV has hundreds of these chips inside a single vehicle. In recent years, Chinese makers have rapidly gained presence in the power semiconductor field. Some European automakers have already incorporated Chinese-made power chips into their supply chains. The chips are price competitive, The quality has reached a usable level, and so adoption has steadily grown. The EU's reason for pursuing these restrictions on security grounds is understandable. With geopolitical risk on the rise, a supply chain that's dependent on China is fragile. But the problem here was timing and ignoring the reality on the ground. Reduced dependence is one thing. Cut it off right now is a completely different story. What does it actually take to swap automotive semiconductors from one supplier to another? The first unavoidable step is meeting a reliability standard called AEC-Q. AEC-Q is an international quality and reliability standard for automotive semiconductors established by the auto industry itself. If a chip hasn't passed AEC-Q, you cannot use it in a vehicle. Resistance to temperature variation, operational lifetime, resistance to electrical stress, there's a long list of strict test items, and clearing them takes significant time and money. Passing AEC-Q is not the end. Next, you have to go through a process called PPAP, a mass production approval process. PPAP stands for Production Part Approval Process, and it's a procedure for proving that a new part can be made reliably and consistently at production volumes. It starts with sample submission and includes audits of the manufacturing process, submission of quality data, and many other steps. From the time a sample arrives to the time the automaker formally approves the chip for use, PPAP typically takes anywhere from several months to over a year. Only when you've cleared both AEC-Q and PPAP are you actually at the starting line. And beyond that, there's still the lead time problem. Even after you find an alternative supplier and clear AEC-Q and PPAP, ordering the chip and actually receiving it usually takes several more months. Semiconductors take time to manufacture. Wafer processing, testing, packaging, then shipping. You can't suddenly place a huge order and expect the production line to absorb it. Time to find an alternative, time to clear AEC-Q and PPAP, time to actually receive the chip. Stack those three together, and you start to see just how hard a quick switch really is. With that industry reality in mind, let's look at the rules from JEDEC, an international semiconductor standards body. JEDEC sets the standards used across the chip industry, including for automotive semiconductors. Under JEDEC rules, even when a maker is simply discontinuing a product, they're required to give customers a minimum grace period of 6 to 12 months or longer. Just ending a product line on its own demands that much grace period as an industry norm. And yet the original sanctions were demanding a cutoff in roughly a single month. AEC-Q takes several months to over a year. PPAP takes several months to over a year. Chip lead times add several more months. Stack those up, and you're talking at least a year minimum. When JEDEC itself requires 6 to 12 months of grace just for a simple end of life, demanding a switch in 1 month is a request that completely ignores industrial reality. The auto industry's outcry was the only natural reaction. Faced with that pushback from the field, the European Commission had no choice but to pivot toward allowing exceptions. It's a realistic decision, but the right time to have these conversations was before the policy direction was even set. If, at the stage of deciding the sanctions, the voices from the field had been heard, what's actually required for a switch, and how long does it really take? The kind of confusion we saw this time could have been avoided. Let me step back and consider the bigger picture, the relationship between geopolitical risk and the supply chain. As geopolitical risk rises, reducing dependence on any single country is an important goal. But if you try to force that reduction on a short timeline, all you create is the kind of confusion we just saw on the ground. Reshaping a supply chain takes long-term planning and investment, measured in years, not months. Let me sum up today's points. The EU tried to restrict Chinese-made power semiconductors on security grounds, but had to pivot toward allowing exceptions under strong pushback from the auto industry. Behind that pushback are 3 unavoidable hurdles in switching automotive chips: clearing the AEC-Q reliability standard, going through the PPAP mass production approval process, and dealing with semiconductor lead times.
Even JEDEC, the industry standards body, requires 6 to 12 months of grace for a simple end of life. The fact that the original policy demanded a switch in roughly 1 month, that's the gap between the policy and the reality on the ground, and that's the root cause of the confusion. Addressing geopolitical risk is necessary, but a policy that ignores the reality on the ground simply will not function.
Now for my own view. Frankly, this is a case of badly underestimating what semiconductors actually are. Beyond anger, I'm just exasperated. 31 years in this industry. I know in my bones how strict the evaluation and certification process for automotive chips really is. AEC-Q and PPAP aren't paperwork formalities. They're systems built to protect human lives. It's fine for politicians to talk about security, but the idea that you can just switch demonstrates a complete misunderstanding of the semiconductor industry. The EU's pivot to exceptions this time is a realistic move, but geopolitics and industrial policy cannot be separated. Even if you want to push decoupling over the long term, you'll hit a wall every time if you move without listening to the field. I hope this episode becomes a lesson, that industry input gets brought in from the policy design stage going forward. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.